Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters. So we are going to solve this problem in three ways, in three parts. So this is the part 1 with one way. Okay, so let's get going. Problem: solve y double dash minus 2y dash plus 2y equal to e power x tan x, or d square minus 2d plus 2 into y equal to e power x tan x. Here we have written this equation. This is an operator form. This is an equation in operator form of the first equation. Okay, let's see. And also we are given differential equation of order 2. Given differential equation y double dash minus 2y dash plus 2y equal to e power x tan x. We can write y double dash as d square y by dx square, or we can ask the same equation as y2 minus 2y1 plus 2y equal to e power x tan x. Here y double dash is nothing but derivative of, double derivative of y with respect to x, and y dash is nothing but dy by dx. Okay, don't get confused if you are asked y2 minus 2y plus 2y equal to e power x tan x. Okay, if you are asked to solve equation in this form, minus 2 into dy by dx plus 2y equal to e power x tan x. Now let's replace d by dx with differential operator d. Okay, so we can write d square y by dx square as d square y minus 2 into, we can write dy by dx as dy plus 2y equal to e power x tan x. Now take y common from all the three terms of LHS, then we'll get d square minus 2d plus 2 into y equal to e power x tan x. Consider the first equation as equation 1 and the equation in operator form as equation 2, which is in operator form, say f of d into y equal to some function of x. Okay, where f of d is d square minus 2d plus 2 and r of x is e power x tan x. Right? And now we'll write the homogeneous equation of equation 2. The homogeneous equation of equation 2 is d square minus 2d plus 2 into y equal to 0. Consider it as equation number 3. Now let's find the solution of the homogeneous equation, and later we'll find the general solution of equation 2 or equation 1 using the solution of equation 3. The auxiliary equation is f of m equal to 0, where f of m equal to, we are having f of d square minus 2d plus 2, right? Let's replace the differential operator with m, so that we'll get f of m equal to m square minus 2m plus 2. Then f of m becomes m square minus 2m plus 2. Now coming to the auxiliary equation, which is m square minus 2m plus 2 equal to 0. Now we need to find the roots to this equation, so we'll use the quadratic formula to find roots of this equation. Roots is given by m equal to minus b plus or minus square root of b square minus 4ac by 2a. Now just compare this equation with Quadratic equation, say am square plus bm plus c equals to 0. Then we'll get a equal to 1, b equal to minus 2 and c equals to 2. Now just substitute in this formula, we'll get minus of minus 2 plus or minus square root of b square minus 2 whole square minus 4 into 1 into 2 by 2 into 1, which is equals to 2, plus or minus square root of minus 2 whole square is 4 minus 4 2s are 8 by 2. This is equals to 2 plus or minus square root of 4 minus 8 is minus 4 by 2. We'll get 2 plus or minus square root of, we can write minus 4 as minus 1 into 4 by 2. This is equals to 2 plus or minus. Now split the square root of minus 1 into 4 as square root of minus 1 into square root of 4 by 2. Since we know that square root of minus 1 is I and square root of 4 is 2. So we'll get 2 plus or minus I into 2 by 2. Now take 2 common from the numerator, you'll get 2 times 1 plus or minus I by 2, which is equals to 1 plus or minus I. Therefore, m equal to 1 plus or minus I. The roots are complex conjugate. So we got complex conjugate roots 1 plus or minus I, right? And if m equal to, we know that if m equal to a plus or minus ib, then the solution of homogeneous equation is given by y equal to e power ax into some constant into cos bx plus another constant into sin bx. See here, I have taken C3 and C4 as an arbitrary constants instead of C1 and C2 because I wanted C1 and C2 to appear in the final answer. Okay, fine. Now let's write the solution of homogeneous equation. The solution of homogeneous equation, which is equation 3, is y equal to e power. Now compare 1 plus or minus I with a plus or minus ib, then for a equal to 1 and b equal to 1, we'll get e power 1 into x into c3 cos bx plus c4 sin bx, which is equals to e power x into c3 cos x plus c4 sin x. Or we can write it as c3 e power x cos x plus c4 e power x sin x. Okay, therefore y equal to c3 e power x cos x plus c4 e power x sin x. Let y equal to, now replace the constants or parameters with functions of x, a and b, then we'll get a e power x cos x plus b e power x sin x. B, the general solution of equation 1 or equation 2. Okay, both the equations are same. Okay, now we need to find a and b. Okay, here a and b are functions of x. Let's now find y dash and y double dash. Here y is equals to a e power x cos x plus b e power x sin x is the general solution of 1 or 2, is nothing but it is a solution of this equation, right? So it should satisfy this equation. So we can substitute y in this equation, y dash and y double dash, right? So let's see. We are having y equal to a e power x cos x plus b e power x sin x, right? Let's find a dash. Sorry, y dash. Y dash equals to a e power x cos x whole dash plus b e power x sin x whole dash. This is equals to, here consider a as u and e power x cos x as v. So we are going to apply uv whole dash formula. Uv whole dash equals to u dash v plus v dash u, right? We'll get a dash into e power x cos x plus a into e power x cos x whole dash plus b dash into e power x sin x plus b into e power x sin x whole dash, right? This is equals to a dash e power x cos x plus a into, now find the derivative of e power x cos x whole dash. Again you have to apply uv whole dash here. We'll get e power x whole dash into cos x plus e power x into cos x whole dash, okay, plus b dash e power x sin x plus b into, find the derivative of e power x sin x whole dash using u v whole dash formula. We'll get e power x whole dash into sin x plus e power x into sin x whole dash, right? Then this becomes a dash e power x cos x plus a into e power x whole dash is e power x into cos x plus e power x into derivative of cos x with respect to x is minus sin x plus b dash e power x sin x plus b into derivative of e power x with respect to x is e power x into sin x plus e power x into derivative of sin x with respect to x is cos x, right? Which is equals to a dash e power x cos x plus a into e power x cos x plus into minus minus e power x sin x plus b dash e power x sin x plus b into e power x sin x plus e power x cos x. This becomes a dash e power x cos x plus a e power x cos x minus a e power x sin x plus b dash e power x sin x plus b e power x sin x plus b e power x cos x. Let's now write the terms involving a dash and b dash first. We'll get a dash e power x cos x plus b dash e power x sin x plus, now write the remaining terms, a e power x cos x minus a e power x sin x plus b dash e power x sin x plus, b e power x sin x plus b e power x cos x. 1, 2, 3, 4. 4 terms. Well, now let a dash e power x cos x plus b dash e power x sin x equals to 0, so that a double dash and b double dash will not appear in y double dash. Or while finding y double dash, we won't get a double dash and b double dash there. Okay. Let a dash e power x cos x plus b dash e power x sin x equal to 0. Consider it as equation number 4. Then this becomes y dash equals to 0 plus a e power x cos x minus a e power x sin x plus b e power x sin x plus b e power x cos x. From this we'll get y dash equals to a e power x cos x minus a e power x sin x plus b e power x sin x plus b e power x cos x. So this is the required y dash. Let's now find y double dash, that is derivative of y dash. Now we are going to find y double dash. This is equals to a power x cos x whole dash minus a power x sin x whole dash plus b power x sin x whole dash plus b e power x cos x whole dash. This is equals to, here also we are going to apply uv whole dash formula. Consider a as u and e power x cos x as v, then we'll get a dash e power x cos x plus a into e power x cos x whole dash minus a dash into e power x sin x plus a into e power x sin x whole dash plus b dash into e power x sin x plus b into e power x sin x whole dash plus b dash into e power x cos x plus b into e power x cos x whole dash. Okay, this becomes a dash e power x cos x plus a into, now apply uv whole dash formula, we'll get e power x whole dash into cos x plus e power x into derivative of cos x whole dash minus of a dash e power x sin x plus a into e power x whole dash into sin x plus e power x into sin x whole dash plus b dash e power x sin x plus b into e power x whole dash into sin x plus e power x into sin x whole dash plus b dash e power x cos x plus b into e power x whole dash into cos x plus e power x into cos x whole dash. This becomes a dash e power x cos x plus a into e power x whole dash, derivative of e power x with respect to x is e power x into cos x plus e power x into derivative of cos x whole dash is, derivative of cos x with respect to x is minus sin x minus of a dash e power x sin x plus a into derivative of e power x with respect to x is e power x into sin x plus e power x into derivative of sin x with respect to x is cos x plus b dash e power x sin x plus b into derivative of e power x with respect to x is b e power x into sin x plus e power x into derivative of sin x with respect to x is cos x plus b dash e power x cos x plus b into derivative of e power x with respect to x is e power x cos x plus e power x into derivative of cos x with respect to x is minus sin x. Now the above equation becomes a dash e power x cos x plus a e power x cos x plus into plus into minus minus a e power x sin x minus of a dash e power x sin x plus a e power x sin x plus a e power x cos x plus b dash e power x sin x plus b e power x sin x plus b e power x cos x plus b dash e power x cos x plus b e power x cos x plus into plus into minus b e power x sin x, right? It's y double dash, okay, not y dash. Then y double dash equals to a e power x cos x, a dash, right? It's a dash. So we'll get a dash e power x cos x plus a e power x cos x minus a e power x sin x minus a dash e power x sin x minus into plus minus a e power x sin x minus into plus minus a e power x cos x plus b dash e power x sin x plus b e power x sin x plus b e power x cos x plus b dash e power x cos x plus b e power x cos x minus b e power x sin x. So here plus b e power x sin x minus b e power x sin x gets cancelled and plus a e power x cos x and minus a e power x cos x gets cancelled. Then y double dash results to a dash e power x cos x minus a e power x sin x minus a dash e power x sin x minus a e power x sin x plus b dash e power x sin x plus b e power x cos x plus b dash e power x cos x plus b e power x cos x. So we got y double dash here and already we have y dash and y. So let's substitute all these three in equation 1. We have equation 1 y double dash minus 2y dash plus 2y equal to e power x tan x, right? Substitute y dash and y double dash in 1, then we get y double dashes a dash e power x cos x minus a e power x sin x minus a dash e power x sin x minus a e power x sin x plus b dash e power x sin x plus b e power x cos x plus b dash e power x cos x plus b e power x cos x minus 2 into y dash a e power x cos x minus a e power x sin x plus b e power x sin x plus b e power x cos x plus 2 into y a e power x cos x plus b e power x sin x equal to e power x tan x. This equation becomes a dash e power x cos x minus a e power x sin x minus a dash e power x sin x minus a e power x sin x plus b dash e power x sin x plus b e power x cos x plus b dash e power x cos x plus b e power x cos x minus 2 into a e power x cos x minus into minus plus 2a e power x sin x minus into plus minus 2b e power x sin x minus into plus minus 2b e power x cos x plus 2a e power x cos x plus 2b e power x sin x equal to e power x tan x, right? Now cancel minus 2b e power x sin x and plus 2b e power x sin x and plus 2a e power x cos x minus 2a e power x cos x. Okay. Then the above equation becomes a dash e power x cos x minus, first I am writing the terms involving a dash, okay? A dash e power x sin x, now write the terms involving b dash e power x sin x plus b dash e power x cos x okay. Here you are having minus a e power x sin x minus a e power x sin x, which is minus 2a e power x sin x, and now add these two. B e power x cos x plus b e power x cos x is 2b e power x cos x, right? And write these two terms plus 2a e power x sin x minus 2b e power x cos x equal to e power x tan x. So here minus 2a e power x sin x plus 2a e power x sin x gets cancelled, and plus 2b e power x cos x minus 2b e power x cos x gets cancelled, right? This becomes a dash e power x cos x minus a dash e power x sin x plus b dash e power x sin x plus b dash e power x cos x equal to e power x tan x. Now consider it as equation number 5. Now we'll solve equation 4 and equation 5 to find a dash and b dash, so that we can find a and b using a dash and b dash. Okay, let's see. We have equation 4, a dash b dash cos x, sorry, it's a dash e power x cos x plus b dash e power x sin x equal to 0, and equation 5, a dash e power x cos x minus a dash e power x sin x plus b dash e power x sin x plus b dash e power x cos x equal to 0, which is equation number 5, right? So in order to solve this, we'll first observe the first terms of the two equations. So in equation 4, we are having a dash e power x cos x as your first term, and here we are having a dash e power x cos x, right? So it's easy to solve, right? Let's solve equation 4 and 5. Solving 4 and 5. Okay, here you're having RHS part, right? You'll have RHS part e power x tan x. Okay, because in the RHS you're having e power x tan x, so you'll get e power x tan x. Now change the signs. Here plus a dash e power x cos x and minus a dash e power x cos x gets cancelled, and b dash e power x sin x and minus b dash e power x sin x gets cancelled, and we'll get plus a dash e power x sin x minus b dash e power x cos x equal to minus e power x tan x. Now consider it as equation number 6. Again, let's solve 4 and 6. Just observe these two terms, first term of fourth equation and first term of sixth equation. So if you observe these two, in order to solve these two equations, we need a sin x here and cos x here, right? So let's multiply sin x to equation 4 and cos x to equation 6. Okay, then I'll get a dash e power x sin x into cos x plus b dash e power x sin x into sin x, sin square x equal to 0. Now multiply this equation with cos x, we'll get a dash e power x sin x into cos x minus b dash e power x cos x into cos x is cos square x equal to minus e power x into tan x into cos x, right? Now change the signs. Here plus a dash e power x sin x and minus a dash e power x sin x cos x gets cancelled, and we'll get b dash e power x sin square x plus b dash e power x cos square x equal to e power x tan x into cos x. Now take sin square x, b dash e power x common from these two terms. We'll get b dash e power x times sin square x plus cos square x equal to e power x tan x into cos x, right? Since sin square theta plus cos square theta equal to 1, so sin square x plus cos square x can be replaced by 1. We'll get b dash e power x into 1 equal to e power x into, we can write tan x as sin x by cos x into cos x. Here cos x gets cancelled and we'll get b dash e power x equals to e power x sin x. Now take this e power x to RHS, then we'll get b dash equals to e power x sin x by e power x. Here also e power x gets cancelled and we'll get b dash equals to sin x. Therefore, b dash equals to sin x, right? We got b dash equals to sin x. By substituting b dash in equation 4, we'll get a dash. We have equation 4, a dash e power x cos x plus b dash e power x sin x equal to 0, right? Now substitute b dash here or take the second term to RHS, we'll get minus b dash e power x sin x. Let's now substitute b dash, we'll get minus of sin x into e power x sin x, which is equals to minus e power x sin x into sin x is sin square x. Now take e power x cos x to RHS, we'll get a dash equal to minus e power x sin square x by e power x cos x, where e power x gets cancelled and we'll get a dash equals to minus sin square x by cos x. Therefore, a dash equals to minus sin square x by cos x. Finally, we got a dash and b dash. Let's find a and b here. Let's begin with a dash. We have a dash equal to minus sin square x by cos x. Since we know that sin square theta plus cos square theta equal to 1. Now take this cos square theta to RHS, then we'll get sin square theta equal to 1 minus cos square theta, right? So let's replace sin square x with 1 minus cos square x, then we'll get minus of 1 minus cos square x by cos x. Here you're having two terms in the numerator and one term in the denominator, so we can replace the total expression into two terms. We'll get minus of 1 by cos x minus cos square x by cos x, right? Is equals to minus 1 by cos x minus, if 1 cos x gets cancelled, you'll get cos x here. This is equals to minus of, since we know that secant theta equal to reciprocal of cos theta, then we can replace reciprocal of cos x with secant x, which is equals to minus secant x plus cos x. Now we are having a dash equals to minus secant x plus cos x, right? So Let's write a dash, or we know that a dash is derivative of a with respect to x, right? So we can write a dash as dA by dx equal to minus secant x plus cos x. Let's separate the variables. In order to separate the variables, we'll take the differential dx to RHS, then we'll get dA equal to minus secant x plus cos x into dx. Here we can perform integration, or we can write one more step where the variables are separable. So we can perform integration. Integral dA equal to minus integral secant x dx plus integral cos x dx. Since we know that integral secant theta d theta equal to log mod secant theta plus tan theta, and integral cos theta d theta is sin theta, and integral d theta is theta. By applying this formula, we'll get integral dA equal to minus integral secant x dx is log mod secant x plus tan x plus integral cos x dx is sin x plus integral constant is c1. So we got a here, right? Therefore a equal to minus log mod secant x plus tan x plus sin x plus c1. Let's now find b using b dash equals to sin x. We have b dash equals to sin x. We can write b dash as derivative of b with respect to x. Now separate the variables. In order to separate the variables, let's take the differential dx to RHS, then we'll get db equal to sin x dx. Here the variables are separable. So let's perform integration. Integral dB equal to integral sin x dx. Since we know that integral d theta equal to theta and integral sin theta d theta equal to minus cos theta, so we'll get integral dv is b equal to integral sin x dx is minus cos x plus integral constant is c2. Therefore b equal to minus cos x plus c2. We got b. We got a and b. Let's now write the general solution using y equal to a e power x cos x plus b e power x sin x. Therefore, the general solution of 1 or 2 is given by y equal to a e power x cos x plus b e power x sin x. Let's substitute a and b here. Y equal to a minus log mod secant x plus tan x plus sin x plus c1 into e power x cos x plus b minus cos x plus c2 into e power x sin x is equals to minus e power x cos x into this term is e power x cos x into log mod secant x plus tan x plus sin x into e power x cos x is e power x sin x cos x plus c1 e power x cos x plus into minus e power x sin x into cos x plus c2 e power x sin x. Here we can cancel plus e power x sin x cos x and minus e power x sin x cos x, then we'll get c1 e power x cos x plus c2 e power x sin x minus e power x cos x into log mod secant x plus tan x, or take e power x common from these two terms, we'll get e power x times c1 cos x plus c2 sin x minus e power x cos x log mod secant x plus tan x. This completes the problem. So we have seen one way of solving the given differential equation using variation of parameters method in this video. I hope you'll understand the problem, and we'll see you in the next video. Until then, bye bye. So let's see part 2 and part 3 in other two videos. Bye.